angles of polygons. Now this is very often during the holiday Christmas season because it's at the end of chapter 6, which is end of first semester. So we're going to have a little fun with some festive clip art here. But we'll start with Theorem 6.1, which is in actually the middle of your page. Down below it says Theorem 6.1, and that is what we call the interior angle theorem. We're looking at polygons, multi-sided figures. And this theorem says, for the interior angles of polygons, if a convex polygon has n number of sides, and S is the sum of the measures of its interior angles, then S, which is the sum, the total of the interior angles, will equal 180 times n minus 2. So you take the number of sides minus 2 times 180, and you'll have the total of all the angles on the inside of any polygon. All right, so let's look at some of the polygons. We're going to give them names, how many sides, and then look at the sum of their interior angles. So we'll start with the triangle, okay? Now a triangle, of course, has 3 sides. Now, the number of triangles, if we draw diagonals here, we still just have one triangle, okay? Now, the sum of the interior angles, if we take n minus 2, so 3 minus 2, that's 1, times 180, we get a total of 180. And we know that is the sum of the interior angles in a triangle. All right, let's look at a quadrilateral. This is any 4-sided figure. All right, so the number of sides is 4. The number of triangles then would be 2. And that's basically going from one corner to the opposite corner. You would end up with 2 triangles. Now, the sum of the interior angles in a quadrilateral, we take 4 minus 2, so that's 2 times 180. The total is 360. Continuing to the pentagon with 5 sides, if we drew diagonals from one vertex, we would end up with 3 triangles. And the sum here is going to be that 3, which is 5 minus 2 times 180, and the total is 540. Next, we have hexagon with 6 sides, 4 triangles, if you draw the diagonals. And the sum then will be 180 times 4. So the sum of the interior angles in a hexagon is 720. All right. Next, we have the heptagon, which is 7 sides, 5 triangles on the inside, and the sum is 180 times 5, okay? The total is 900 in a heptagon. Any 7-sided figure will have a total of 900 degrees on the inside. All right, octagon has 8 sides, and diagonals form 6 triangles. Sum of the interior angles is 180 times 6, so the total is 1080 inside an octagon. The 9-sided figure is called the nonagon. We end up with 7 triangles if we draw the diagonals, and the sum of the interior angles is 1260, 180 times 7. Now, for other figures that have different number of sides, we don't have special names. We just call it the n-gon when it has n sides. So if it had 15 sides, we would call it the 15-gon. All right, we still use the formula n minus 2 times 180 to give us the total of the interior angles. All right, so we're going to skip to naming the polygons at the bottom of the page here, and you can look at those and give those names, but let's here go to the interior angle theorem again, once again, which says the sum of the interior angles equals 180 times n minus 2. So let's do a few of these outside of the chart. It says find the interior sum. So for number 10 here, we have to count the number of sides. I need to know what is n, the number of sides. So if you count here, you would get n equals 11. That's super important. You need to know how many sides. Next, use the formula. 180 times 11 minus 2. That was n minus 2. So 180 times 9 gives me the total 1,620, and that's the total for all these angles added up inside this 11-sided figure. Number 12. Let's do number 12. Here is an octagon. So here we're going to say 180 times 8 minus 2. 180 times 6. The total inside the octagon is 1,080. That's like a stop sign. Okay? And the middle one then is a heptagon, n equals 7. Just practicing with the formula, 180 times 7 minus 2 will give me the total 900 for all the angles inside the heptagon added up. Okay? All right. So now I want you to try some of these. Okay? 13-agon, 180 times 13 minus 2. The total is 1,980. So it's pretty simple to use that formula. If we have a 32-sided figure, we would say 32 minus 2 and then times 180. Total would be 5,400 degrees inside a 32-sided figure. Now a 12-gon is often called a dodecagon, so it does have a special name. And in this case, 180 times 10, the total is 1,800. All right, so now let's look at a corollary to that polygon angle sum theorem. So regular polygons are special polygons. They have all congruent angles and all congruent sides. Now, the measure of each interior angle in a regular n-gon, meaning any number of sides for this regular polygon, the formula looks like this. 180 times n minus 2. Now that gives me the sum inside the polygon, but to get one angle, one interior angle, you're going to divide by the number of sides, and that will give you one angle. All right, and we're mostly going to look at regular polygons. So all the angles are the same, all the sides are congruent. So again, here we are at the octagon. All right, n equals 8. So to find one interior angle here, we take 180 times 8 minus 2, so that's 180 times 6, and then divide by the number of sides. Now, in an octagon, there are 8 sides, but there are also 8 angles. So when we say n is the number of sides, it could also be the number of angles. All right, here we are. When we do the math here, we get one angle inside this octagon is 135, and that's going to be inside every regular octagon will be 135 degrees for that angle. Okay, so that means this angle, each angle is 135. Okay, all right. Now, number 15, I want, if your last name is in the, say, A through F. If your last name is A through F, you're going to do number 15 and bring it to me when we meet. All right, number 16 is going to be G through L. Number 17 is M through R. Number 18 is S through B. And number 19 is W through Z, okay, if there is one. All right, A through F had number 15. G through L had number 16. M through R is number 17. S through V is 18. And W, X, Y, Z is number 19. So work that problem. Bring me the measure of one interior angle in your shape. Okay, so now we have another theorem. 6.2 is the exterior angle sum theorem. Now, in a convex polygon, the sum of the measures of the exterior angles is 360 degrees. So it doesn't matter how many angles, they will total 360 on the outside. So remember what we said, an exterior angle is if you extend one side of the figure, you get an exterior angle. And here, in a triangle, we have 180, but on the outside, we have 360. Here we have a quadrilateral. The outside angles will add up to 360. Okay, this is for regular polygons. One exterior angle equals 360 divided by n. So that's when it's a regular polygon. If all the sides are the same and all the angles are the same, each exterior angle will be 360 divided by n, the number of sides. Okay, here this is a hexagon, 6 sides. So we take 360 divided by 6. Each exterior angle is 60. All right. So here, find the measure of an exterior angle given the number of sides in a regular polygon. All right. So that's going to be 360 divided by the number of sides. 360 divided by 15 over here. 360 divided by 8. So see, you have what each exterior angle would be. All right. And for number 18, when you have 11 sides, 360 divided by 11 equals 32.7. Sometimes you get a decimal on those. All right. So now this is not a regular polygon because the sides are not all congruent, but we still know with 5 sides, we know the total is 540 for all those angles. So in order to solve for x, I'm going to add up what I know about each angle, add it up, set it equal to 540, and then I can combine like terms. I have 26x plus 20, all the x's together, all the numbers together, subtract 20, and divide by 26 so I can figure x equals 20. So that concludes 6-1. I will see you next time.